do a post on LinkedIn, notify everybody, and then if you wouldn't mind just commenting on LinkedIn that you'd like the recording, and we'd appreciate that. So it's certainly that engagement on LinkedIn helps us a lot. It helps people see that things are happening. If you want to chat a little bit further, happy to chat on LinkedIn or online or afterwards once you stop the recording. The presentation, so this is the presentation deck. We can make it available. Estie, is that okay with you? Okay, fantastic. All right, so we can publish it. We'll publish it with the recording. Okay, so just from a training point of view, this is March. These are the sessions that we're going to have. So we will be having data ontology and data privacy this week as part of the DAMA meetings, and then we'll have the DAMA user group meeting next week.
Howard,
yes.
I'm not seeing that next slide. I'm still seeing the first slide.
Oh, you know what?
Might just be me.
Okay, sorry.
But yes.
Okay, I'm actually moving the wrong desk. Okay, so again, data ontology today, data privacy on Wednesday, and what we will be doing is connecting all of the data management areas to setting up data privacy on Papaya, and just actually doing that mapping and linking between what do you have to do from a data management point of view to be privacy compliant. The week after next is next week, that's the DAMA user group. Then we have also on the Tuesday, we have data and culture change. So Christine, these are coffee sessions. What we're trying to do there is allow Christine and Costa to share ethical challenges that have come out in the news, both positive and negative, and then for us to discuss them. So there won't be as formal presentations as this. I think we're trying to get to a point where we're having more interaction and more discussion-based learning for data ethics. And then our big data is moving because we have a holiday on Monday. It's Human Rights Day for us on the 21st. So the big data one will be moving to the next week. And then we will have the speaking data every Thursday. I think the post may have gone out or should be going out very soon. We have the QDMP CNA question and answers. So anybody interested in doing the CDMP exam or would like to understand a little bit more, Veronica does that every Friday. She certainly gives you all sorts of tips and helps. And there's the refresher day on the 26th. Okay. All right, then in terms of training, we just finished the how to analyze data last week. Connie did really well. We had data management for certification that's running this week, and that's the two major training for this month. And then we'll start again next month with master data and data governance. Okay, so at this point, I'd like to just say welcome to everybody, and once again, thanks so much to Estie for preparing and doing everything. And Estie, if you wouldn't mind taking over, and all yours.
Okay, cool. I will take over, and then let's see if the same thing happens to me that happened to you. You know, if you're switching the wrong.
Mine was Pepcake.
Mine might be as well, eh? Mine might be as well.
That looks good.
Does it look good?
Yes.
Okay, cool. And if I now go to the next one, it goes.
Yes, that's ontology definition. I thought it was a view of Julie, but
that actually would have been great. That actually would have been great. So context for those who don't know, Julie is our bulldog, and she's sitting by my feet and tends to snore. Normally loud enough that everybody can hear. Fortunately, you can see me speaking, so you'll know I'm not the one snoring during the presentation. So, yeah. So this month, we're learning a lot about data ontology and ontology in general. So ontology is in computer science and information science, it encompasses a representation, formal naming, definition of categories, properties, and relationships between concepts, data, entities. And you'll also notice that a lot of the modeling terms that us as data modelers also encounter is also part of this representation, formal naming, definition of categories, different properties, and different relationships. Those are all things that we as data modelers would be very familiar with. There are some new terms, though, when it comes to ontology. So domains of discourse and multiple levels. So subject area domains, conceptual model domains, and attribute domains. Now we're going to chat a bit about where does ontology come from, the word itself. So ontology is parts of philosophy, and there is 3 specific branches of philosophy: metaphysics, what is real; epistemology, how do we know; and axiology, what is right. And in essence, ontology tries to think about and answer questions about existence and being. And if we apply that to data, or a subject area, or a domain of discourse, that is to see what about this area or subject or domain of discourse, how does it exist? How is it? So it's, I think, definitely an introduction to a lot of philosophy on data management, which I'm quite enjoying at the moment. Chatting with Howard, this is also like, this is not new. Ontology in general, and then ontology in computer science is also not new per se. It's a domain of discourse. So there's a couple of items, so I'm just going to start with the left. So there's constant symbols, which represents individuals in the world. So Mary, the number 3, green. Functional symbols, which map individuals to individuals. So father of Mary is, for example, John, and the color of the sky is blue. And you have predicate symbols, which map individuals to truth values. So, for example, 5 is greater than 3. Grass is green. The color of grass is green. So you have very many ways of formally representing all these different items and terms in taxonomies. So universe of discourse. And also related to then elementary algebra, number theory, the universe of discourse could be numbers. So think real, complex, rational numbers. And in this example, this domain of discourse, I'm getting a bit of feedback.
Okay, I've put it on mute. Sorry, Estie.
Cool. No, all good. Thanks, Howard. So domain of discourse example from South Africa, from a view of higher education. So there are these different domains. So there's an official domain, which includes institution, vision, mission, policy, regulation, some national bodies. There's a social domain with intersubjective relationships between individuals, attitudes, orientations, behavior. There's more teaching domain, academic disciplines, institution, curriculum, production, reproduction in academia. How do we bring these entities all together? How do we connect them? And I'll looking at this, and then also thinking about if you're attending the Thursday sessions, we're also talking about sustainability and ontology there. How do we bring different external taxonomies such as SASB or other bespoke taxonomies? How do we bring them together, and how do we make sure we move along the chain and see what inferences there are between them? You know, we want to see the data and the metadata at the same time. And then I heard Howard use a very visually appealing picture for this, to say Lego blocks that we build together. How can we build these Lego blocks together to see different visualizations, different views, but it's still the same model. It's still the same Lego blocks.
Yep.
And this is a very large picture of an ontology. that shows the labeled graphs in the model, and these show some WordPress articles. The intention is not really to show specific items, but just to get an idea of how large these concepts can be. So from media, geography, publications, government, cross-domain, life sciences. And even though there are in life sciences perhaps more interrelations between them, there are definitely interrelations between the different subject areas as well. How do we bring these different domains and elements together? And then also a discussion about how can we not just spend as data modelers, spend our time talking to subject matter experts, documenting models, seeing how they're designed. How can we start from sort of a combination of both? How can we start from the bottom to see what is the data actually telling us about what the structure in this model should be looking like? And then I think the value would lie in there a lot, the comparison between what the world, the SME, or the world that we perceive it to be, and what the actual data says.
And maybe just to ask some questions there, Estie, because when we chatted to you and JG on Thursday, we noticed that for sustainability there are several taxonomies. So if we were to almost analyze someone's balance sheet, there may be a requirement to be, when we're looking at a line item on the balance sheet or an area on the balance sheet, that we could view it through one domain of discourse, being SASP, and then convert that to another domain, and to be able to jump around and see how the overlaps come along. And I think what we were trying to discuss is we want to be able to listen to the data more. So almost when we ingest these balance sheets from all your customers, and we bring in these different domains, let's say we've already got 100,000 balance sheets that have been loaded. They've been mapped to the original 3 sustainability taxonomies, and then we bring on another one. And sort of almost what's the process of mapping that data to the new domain, or do we take that ontology and map it to other domains and then view the data that way? So how would you see that sort of process working in terms of being able to work both top down, i.e. from SMEs down to the data, or from data to the model?
So my idea almost is that we have those two, and then to do a comparison from either perhaps using some algorithms to see where they are matched, not matched, looking at the actual diagram. So you'll see later on in the Neo4j diagram, everything is very nicely connected, and then there's these 2 nodes that are just not connected to anything anywhere else.
Right.
So I think in that sense, with the data being represented perhaps a bit differently with an ontology, or then even a knowledge graph or a property graph, we might be able to get some insights or be able to ask some different questions with it.
So how would you, I suppose this is the interesting part from me, is if I have an existing knowledge graph with existing domains, with all my discourses there, I bring in a new framework, would you work at linking the data, the XBRL data that is the representation of the balance sheet, to the ontology, or would you link ontologies together and then look at what the data links? So there's almost 2 ways of tackling this, which if you bring in a new discourse, you want to see now, how does that split the universe? How does that distribute, or how does it present the view, and what analytics do we get on that new ontology? Or do we connect the ontologies and then look at the data? So, and I'm assuming, I mean, there's possibility that one could work both ways. That one, either way is maybe helpful, but maybe it is about listening to the data and allowing the data to show us what is there rather than the other way around.
I think definitely merit in that. And I think if there was a lot of time, that would be great to be able to do it both ways. But then once you've almost seen some connections, almost to unsee it and not have that influence you as the data ontologist, to not have that influence you when you're doing it the opposite direction could also be quite interesting to do. But I think both would have quite a bit of merits. What we currently intend to do is to use the different taxonomies and have it import the taxonomy data,
Right.
see some ontologies on top of that, and then do the analysis. So I think at the moment we might have the plan at the moment is almost the opposite way around, but I think yours might, the idea of going from the bottom up could be really fascinating as well.
Yep. So there is a question. There's a question from Anthony, and I think you may get it to a little bit later. He's saying, is there a direct link between this type of data model and a graph DB?
Yes. Yes.
Do you want to answer it later on, or
yeah, I'll answer it. I'll answer it a bit later on.
Okay. All right. Fine.
Okay. So now this comes to, what does an ontologist actually do? So an ontologist is a language maker. They identify things in your business. They gather all the relationship. They provide a consistent standard for usage, grammar, and the idea is to bring order out of chaos, and working across the entire organization. So the whole not siloed thinking, cross-organization, using with that, and ideal to coordinate and advocate for interoperability. We want systems to talk to each other, to be able to understand each other. And that's a lot of the work of the ontologists. So there's definitely some technical work, but there's definitely some change management work. So Christine will be really proud. And we want to create a shared understanding. So now what we do want in data is we want items to be messy, mutually exclusive, collectively exhausted. But this comic actually shows are quite interesting. So science is based on mathematics and maths is based on logic. But is logic as watertight as it seems? So Russell's paradox is a barber shaves only those men who don't shave themselves. But what does this mean? But does that mean he shaves himself or not? So the philosophical questions on many different items for ontologists, I think. So for this Russell's paradox, I don't have an answer for it. If somebody has perhaps some comments on it or anything they've heard of it or experienced with it.
Yeah, I think, certainly for me, Estie, when I build data estates and data topologies, we try to start off with a complete map that goes over that every single entity within our discourse is positioned in the appropriate place. Now, I think what this is certainly saying to me is, when I get these loops type of happening, and they may be happening between subject areas, and let's say each subject is a domain of discourse, then it's almost not part of that set. So we're always trying to say what's in the set and what's out the set, and then is the set part of that domain as well. So there's all these different challenges that we get to in terms of managing the set and the sort of definition of what is in the set and what's out, and then when it's not in the set, what do we do with it? How do we deal with that thing that doesn't fit into the set? So this whole discourse of universal discourse, and then we're finding things that are outside of it. How do we bring it in? And we go around in these circles of trying to position it in the right place.
And do you mostly make those decisions on a basis per project almost to decide, okay, in this case, what do we do here when we run into this obstacle?
Yeah. And I suppose that's, sort of that's where we sort of, a lot of the times we've been dependent on the industry data model, and that sort of already gives us that map. But when you build one on your own without that sort of guidance, you can be flip-flopping between the two, and you can be finding yourself, first of all, believing it's in this subject area, and then it moves out of that domain. And that's an important thing. Is have you defined the criteria about what goes into that domain and what's not part of that domain? And this is what this barber challenge is am I a barber or not a barber?
Mm-hmm.
And you get these cyclical issues that you're challenged with.
And I suppose probably never completely goes away. Somebody else joins the team and they see it differently, then things get updated and changed again, or back and forth.
Yeah. So there's another question, and I think for Emmanuel, what are some of the tools used in data modeling? And we'll show you some of the tools.
Yes. Okay, so what does an ontologist do? And this is also part of the semantic chain, where we start on the left and move to the right on the semantic chain. So lexicographer. Yes, it's what Paul would say for anesthesiologists. I think lexicographer is my kind of tongue twist one.
Lexicographer.
Lexicographer. Yep, definitely mine. Studies word and compiles results into a dictionary or a glossary. Modelers would be people who do computer system engineers who design and implement data modeling solutions using relational, dimensional, and NoSQL databases, like a lot of what a lot of people on this call does. Taxonomies specializes in classifying and sorting information based on an established system. And ontologist is a language engineer, a conlang, short for constructed language. So thinking about what Tolkien did in Lord of the Rings, or inventing Elvish, thinking about different sci-fi, Klingon, Dwarvish, and then another complete area for almost inventing this new language. Sustainability is an entire new language, not new, but it's a different language than what we might be familiar with. So that also needs an entire new words, new meanings added to it. So that's what does an ontologist do, and then some skills that an ontologist.
Maybe the question, Estie, that's something that struck me last week, was that that SASP actually had quite a bit of data privacy in it. Now there are specific ontologies that deal with data privacy and data protection, and it's now about, how do we, if we were to bring on a data privacy ontology, we're going to have almost multiple tags on data line items, which is, in a way, it's good because you can then jump between the different languages or different representations.
Yeah, but it for sure makes it, I think, a bit more complicated as well, because there are so many extra tags, extra items, that it becomes, to a certain point, you do need to know what lens to look through it. Even though it's the same data, it might be finance or sustainability, but that lens that you view it through, I think, helps give us a lot of context. Now, some skills for ontologists: so proficiency with relational and NoSQL databases, good understanding of the difference between the two, an understanding of data modeling principles, dimensional modeling, entity relationship tools, semantic modeling, an ability to work with XML, XSLT2, XQuery, XPath, XSD, as well as to be able to either write or use validators and to validate code and able to query documents in relational databases, the ability to work with JSON, to understand the difference between JSON data and XML data models, the ability to work with RDF, RDFS, OWL, SparkQL, SparkQL 1.1, Spin, or similar extensions. And there's also an increasing new one, SHACL, which I can never remember what it stands for. But so many abbreviations, but a lot of these are, you'll find RDF, RDFS, OWL, those are extensions on files, as well as turtle files. They are extensions that you'll see on files. SparkQL is a way of querying this type of data. And second page, a deep understanding of how REST works, be able to compare REST and SOAP-based service-oriented architectures, be able to write SQL in various variants, DML, DDL, and to distinguish characteristics of inner, outer, cross joins, understand normal forms, talk knowledgeable about advantages of normalized versus denormalized forms, and then the more in-person items, be able to communicate effectively in writing and in person, be able to work with both suits and geeks, be able to use data visualizations tools effectively, understand data governance and data curations, be able to work with network graphs and know the distinction between labeled direction and non-directional graphs, and love words and concepts. Because in essence, you are busy creating a language or assisting a team of people to create a new language for a company, a domain, a subject area, or a new grouping of these domains of discourse together. Now, how do we create a data ontology? So we first need to decide what domain we're going to look at and the scope of the ontology. Then we need to start looking at, is there an existing one or more than one? We don't want to go reinvent the wheel if it's been done before. That's quite a big investigation, as well as for formats to see if it's the same format that you might require, etc. But it's a very good guidance to use existing ontologies. Enumerate important terms, define the classes and the class hierarchies, define the properties of classes, define the facets of the slots, and then to create different instances. And then a discussion that we've also had is, so existing ontologies would be something like SASB that already has some ontologies and taxonomies in. But then the discussion always comes up about data governance, like who owns this piece of data. So you should be able to define the relationship between this data entity and another one. And data ontology might be a good place to start. If we have a community of practice and it's a discussion about the content and the ontology and building the canonical model for what the company sees and how they view it, more than just who owns what pieces of data. With the ontology, you might still find interesting connections that might help later on establish a data governance model. And I think just more and more working in the data space, I just realized that these things take time. Absolutely everything that we want to do takes time.
Sure. Too much time.
Yes, sometimes I think, I don't know, maybe other people can relate. Like, I would love for things just to, ideally when somebody says, it should be finished in 2 weeks. I would love for things to be finished and settled in 2 weeks. But I think working in the data space really teaches you patience as well. I think with yourself and other people as well, because even though I want it to grow that fast, I know that it can't move that fast. It needs time. We need to have discussions, and we need to have discussions maybe twice or 3 times. It's definitely a lessons in patience sometimes as well. So there's an item in Dataversity about data ontology being the future, and has this specific example where veterinarians could browse through concepts by clicking on one link and working through the causative agent. Click on one link and trace it through for multiple disorders and see which items could be linked to which. And this is a very different way of viewing data. So a lot of us now seeing, like, for example, if you Google something, typically also have a page layout on the side that gives some, if you Google a specific person, that might be a celebrity, details on when this person was born, where they studied, where they live, how old they are. That already pops up on the side. And if doing something similar for example, for veterinarians or in health sciences, they could have a different way of traversing through data and knowledge and getting information maybe sooner or in a different way than they did before. So this is very intriguing to me, as well as for what it could do for health science, but also from a knowledge-based perspective at a different company. If you could link this way, like we do when we search Wikipedia, click through items and learn about those specific items.
So, Estie, there's a question from Don, and it's an interesting question. It says, can one really generalize data abstraction as suggested? Different classes of data might have very different definitions, preventing or complicating generalizations for mapping. Would you like to answer that, or would you like me to?
I'd give a stab at it, and then I definitely want to know what you'll also know.
Okay.
I think that comes a bit with the almost narrowing the scope a bit and doing a taxonomy first, and just seeing the different classifications of where things might fit in. Saying that, also just looking at the different sustainability standards and how they classify industries, and looking at all the various different methods and ways different companies and standards classify industries, which is a fairly simple concept without being linked too much. I can already see that being very complicated. So I think it's tough.
I think what is important, the one thing that we need to understand is that data could have multiple connections to multiple pieces of metadata. And I think I shared an example, Don, and I'm hoping this answers your question. For example, a BMW 228 could be linked to the classification of car model, the models, or of car type, luxurious car, whatever it is. So a data item that has found in data the ability to tag it or to connect it into an area or a domain. It's not only going to be it's not forced to have only one domain. But if your categorization is working, and I think Estie was talking about an industry classification, they would have the rules on how they classify an industry. Now, it's certainly possible that one node could have one classification from this domain and a different classification from another ontology. And I suppose that's where some of the excitement comes, or the ability to translate your data from one domain to an alternative domain, but those domains themselves have a universe that they have defined. Don, I'm not sure if that's answering your question.
I think that's really helpful. I guess it is just when you have different data from different domains, it must be really complex to try and generalize taxonomies.
Yeah, I think what you're doing is you're not generalizing so much the data as you're generalizing the classification. So the classification, as Connie points out, there's something called BFO. Those are upper level ontologies. So you classifying the concept more than you're classifying the data. The data, when it's in there as a time series, can then be linked to multiple categorizations. Okay, so it's first of all, it's that design of the language, and then it's then the mapping of the data to the language. But what we've also found, which someone shared with me, they challenged me in one of the areas, and I think it was part of Pascal, where he's actually saying sometimes we need to look at the data and reverse engineer the model from the data, and then see whether that fits into our domain, and not always try to force a high level definition onto the data, but also in some cases reverse engineer that. And we do that a lot in typical data modeling. The SME will say, this is the way I define the GDP concept with its 14 elements, and it's got all these different component types. And then when you go and have a look at the data, you're saying, well, but that doesn't really fit into what you're saying. Now, the nice thing about that discovery mode is we come to a situation of saying, well, is this data incorrect, or is our model incomplete? And we have now the option of either enhancing the model with a categorization, or saying that the data is wrong and it needs to be fixed. So you have a sort of iterative process of discovering what you don't know by new data coming on, and then either increasing your understanding with adding nodes to the taxonomy, or by by saying this data is invalid and there's a fraudulent transaction or whatever that is.
I think this is also thinking about some of the things that we're dealing with that we need to really keep in mind of not necessarily just the ontology, but when it comes to the analytics later downstream, is because these different classifications are in play, certain things are not additive, because they're linked twice, but you should not sum over total procurements and total preferential procurements. You are double accounting.
Yeah.
So yes. It's how we model that and how we convey those specific items. So in an under investigation, because it's something that is very important. Because you do want somebody that is eventually going to do the visuals, Power BI, to know the ontology. But let's say it's somebody new that might not. How do you help them and aid them to not by accident present a visual that is very inaccurate? Yes, I think, Don, I think that's definitely a big challenge. And then an interesting article by Alan Friedman, where he said, last year I requested the name of an entity type to be changed from message type to event severity to more accurately describe and represent the information it contains. The effort to rename the relational database table required 2 engineers, their manager, a program manager, an architect, QA, and deployment engineers, 6 sprints, and around 30 distinct messages on a Jira ticket, and it took 4 months. And that's a lot part of the theory that doing ontology modeling would reduce this process and reduce this high intensity overload to a lot less time. That will definitely need to be tested, I think, in a lot of practical areas to see if it when it grows to be this large, to have all those people working on it, how long that takes, or if it is very flexible. So that is one of the advantages listed with the ontology modeling, is that it's very flexible. But that'll need to be with experience, that once you use it, that you can actually say, yes, it is this flexible, or it is not this flexible. And then I think somebody else's question. So I have a picture in the next slide from Ontotext that gives quite a nice idea of, so we have ontologies, but now when we add the actual data, so ontology is just the structure and how that structure maps to each other. And knowledge graphs or labeled graphs would be when you add the data inside of that structure. So on the left-hand side, it just has plain graph. Then it has knowledge graph, which then uses a lot more subclasses and abilities that they use. And then knowledge graph with inference then also says, for example, so if it's a shoe, boots is a type of shoe, but boots, high boots, is a subtype of boots, but it's also part of shoe. So also the inference that comes with it. So there's some explicit items and then some inference. So this picture I found quite interesting and helpful in illustration. Okay, so up next, something that I use. So I used Gra.fo. I'm just going to go through these 2 slides and then I'm just going to show you. So I used Gra.fo as a tool to be able to, where you can either import your ontology or you can map it. And I've looked at a few tools, and some of the tools have a very large time component of, you need to know how this tool works before you can start doing something. And Gra.fo is quite intuitive, and I think you can start quite easily with that. Then Neo4j has an importer, which is still in beta mode, so there are some glitches to it, but it's also been very handy, where you also build very similar to an ontology. You build how these entities or these nodes relate, and then you can import them into Neo4j, which is then the resulting knowledge graph or property graph, since Neo4j is a property graph, on the right-hand side. And this to me was quite handy, especially if we want to go for see what the data tells us. To set the basic ones up, which pretty much maps the CSV file and be able to import it. I'm going to end the slideshow, and then I'm just going to show you a bit of Gra.fo. So in Gra.fo, you can import existing ontologies. So I've imported this ontology. Thanks, Connie. I know it was one of your recommendations last week to have a look at them. One of these ontologies that is OWL, CSV, RDF, or the difference. I've just exported the OWL one. And then you can go into Gra.fo, maybe literally do it. Click import, then you browse for files with any of those extensions, RDF, OWL, TTL, which is a turtle file, a JSON, or a zip file, and you then import the ontology.
I don't know if you are showing the
right thing. Oh, yes, I am. Yeah, so what can you see?
Just the Explorer.
What do you see?
The Explorer?
Nope, totally not. Okay. Then I'll stop and quickly start sharing again. Okay, let's see. Yes, better. Seeing a tool
Yes.
now.
Yes.
Okay, cool. So then the quantities, units, dimensions, and types ontologies that Connie shared with us last week. So I downloaded the OWL file. I can go to Gra.fo, click on import, and I can import RDF, OWL, TTL, JSON, and zip files. I have, however, noticed that, so I tried to import quite a large ontology from the EU, and that, however, does fail. So I think there is a limitation on how much you can import. It looks to be about 1,000 entities, which is quite big still. But the EU's ontology has a bit more than that. So for large files, we might need to find a different option. But for this specific file on quantities, units, dimensions, I've been able to import it into Gra.fo. The visualization isn't that easy to see. It has quite long items, but you can click on items and then get detail on the left. So ordinal scale. It maintains the data and the definition. So the glossary item, if you will, from the OWL file and imports it with additional data here. You can navigate through items, click on items and view it here. So if you already have the ontology, this could be a good start to import it and potentially link new ones, existing ones, or lay out yours. So I'm going to just go to, so this is if you're starting completely new, this is what it looks like. But you click on new concept and I'll say, okay, so let's person. Okay, this person, and then I want to create, add a relationship or add to a new concept. And I'm going to say, okay, this person goes to school. And now when you click on items, you'll see, okay, there's a label in between. You can add and then build up your ontology, and you can then export it if you go to file. So if you've built up this, export it to various formats. So Toto or OWL, you can export it specifically for Neo4j and different formats. So from easy to understand and easy to use, this one I found quite helpful to at least get started. So you can export it here and then import it. However, I did find when I imported the ontology that I created, that Neo4j there seems to still be a slight bit of a mapping problem, which could be due to me. I'm still figuring out exactly how this needs to work, but you can import that file. There are some items, these red items specifically, that are not on the original map. So I think these are items that they haven't been able to identify. But you can then traverse through your ontology in a knowledge graph environment and then also add contents to these items if you'd wanted to. So this is from that era. Then as well, Neo4j has a data importer. It's still in beta mode, but this has been pretty handy actually as well. Now we just need everything to have very nice interoperability and talk to each other. But in this one, for example, I can browse and I need to select a CSV file. So I have reference data for SASB. Open it and it sees these are the headings inside this file. So I can then go and create and say, okay, I want this one to be called sector. And can click and then it's going to tell me, okay, what file does it need to link to? So it's quite handy to help you. So you can import multiple files and say that data comes from there. And then mapping, add node. You can also, there it is. Okay, so you can also drag it to the next one. So, okay, so sector is the top one, and then it links to industry. And now you'll see there's a lot more pop-up items that say you have to resolve some issues. So sector, so ID, you have to tell, okay, what is the unique identifier in this item? And I need to go to sector, and yes, it is definitely from that one. And then I say, okay, the ID is part of sector. So then they're like, okay, good, happiness sorted. And then you have to, unfortunately, go through this process for all of them. And so it's industry. It also shows the little green item of which ones you've had. You can confirm and then say this one links to industry. And then you also have to give a name of the type of relationship between them. So I can, for example, say sector belongs to industry, also links to that one, and then I just say, okay, this is correct, goes from sector to industry, and then it resolves itself to no longer have any flags or exclamation marks for it. So you can build up your diagram like this and click on the Run Import button. And then it generates in Neo4j, generates your import for you. You do need to make sure that you have some items installed. So you need Neo4j, Neo Semantics installed as a library. But then you can view that import of the actual data in quite a lot of detail. So, for example, if I click on here, I can then find, okay, that is economic, impact investing, ESG investment integration, for example. So this, you can then traverse through it where all the colors also mean different areas in the, where it shows them, different areas or headings in the item. So I did some of the other import, but for the SASB one, if we imported it, would then show sector, industry, topic, counting, metric, category, units of measure, and then the code it gives. And then you would already be able to play around quite a bit. And now you'll see, like, there are some different constellations of things that belong to each other. And then there's odd, like 3 nodes that are just in the middle of nowhere. And that could be a good conversation starter of showing, okay, what probably needs to get discussed based on the data, probably these items, because they're not linked to anything. So this is how we can then start from the data side to say, okay, we need to talk about this.
What don't we know?
What don't we know? Yes. What don't we know?
This is stuff that I don't know anything about.
And I think this can then help for you to then start there and start answering those questions on what don't we know.
So it's almost nice where we go from a property graph that we don't know what it is to the knowledge graph where we've been able to type it.
And this is, so Neo4j is currently is a property graph and not technically a knowledge graph. So they have they're working, I think, for the last couple of years to really expand it to make it RDF compatible as well. So now you can import RDF data and export it in RDF format as well. So you just need a specific that Semantics library for that. But otherwise, Neo4j is actually a property graph and not a traditional knowledge graph. Yes, which was to me very interesting because I hadn't known that before.
Yeah.
Okay.
Fantastic.
Any questions?
Thanks, Estie. Thanks very much. Any questions, guys? I know Emmanuel had, I think it's answered your question. You asked us, does it allow to add relationships? I think Estie saw that. And then David was talking about, how much Neo4j is progressing and making something a lot more friendly than what it was. Any, Simon, I know you had a few statements. I wasn't sure whether there was a question or whether you were just discussing reversing the definition, or how would you, is there something from your side, Simon, that we need to answer? He's quiet. Maybe he had to go. Mr. Grobler, any comments from your side in terms of?
No, this is really, I was just typing actually. It's a fantastic presentation. Nicely done, Estie. I'm still, Howard, you and I had countless conversations about this, especially on Neo4j not being a proper knowledge graph. But I must admit, I still don't quite get why it's not. It's not only a property graph. It's definitely moving towards knowledge. But what would make it a full knowledge?
So what you'll find is in a true knowledge / semantic, and that image. Won't you go back to that image, Estie, on the boots?
Okay, I'm doing that. I'm also opening one of the slides that I was busy trying to answer that specific question for, like, to show, okay, what is the difference between a property graph and a knowledge graph?
And then also to probably, and that one's quite good. So if you wouldn't mind going back.
This one.
Yeah, so if we look at almost that that property graph, Paul, what you're seeing there is node linked to node via an edge. Now, the scenario where you go into Estie, if you go to that other diagram, with that one, what you are now doing, Paul, is are you seeing that you're adding that sneaker has now been connected to the hierarchy of sports shoes? Okay, so you're linking metadata or semantic data to actual data. And there's
but I think you can do that with Neo4j. That's why I'm confused.
No, but that's no. But let me just finish there. It's not. We're not just saying node to node edge scenario. What we are saying that that semantic association with data items. So your property graph on its own it sees everything as data items. There's no discrimination between a data item and a semantic ontology or taxonomy.
Yeah, but then I want to say Neo4j is probably at least the middle one, the knowledge graph. And perhaps not with inference, but I actually need to check that because I think it could be. You can type and subtype nodes.
But can you bring in ontology? That's the question. Can you bring in an RDF and then start the mapping? So don't just look at a node on its own and adding a property to a node. Can you bring in a whole taxonomy with classifications, associations, and connect it to your data?
But what has Estie done then?
But that's what Estie is saying, is she's included the semantic part to Neo4j. So they're adding that semantic functionality on.
Yeah. So
by default, it's just property.
So something that I found quite big that seems to be different between a property graph and a knowledge graph is the property graph is pretty much schemaless. It's very local.
Yeah.
Where knowledge graph, the purpose of it is for interoperability at web scale. So unique items will be everywhere, where if you have property graph, and you might need to integrate it with something else, you at this point in time can't be sure that the one item in one property graph in your company and you link it to the other item, you can't be sure that all the items will be uniquely named, for example. Which is just
also,
one of them.
if you look at that table that you got, that knowledge graph as designed on Gra.fo and can use the international resource identifier. So you almost design your knowledge graph independently using Gra.fo. You can register those resources, and when you then bring that RDF or OWL into the data element and start the association, it's done at almost two separate graphs to an extent, and then you have this mapping between that URI, that language definition, and then the actual element, the node itself. So whilst you could go to each node and do some level of typing, you're not building a knowledge graph and then connecting the knowledge graph to data.
What does Hans say?
Sorry, Paul, what did you say?
No, I'm just reading Hans's comment here.
Well, according to their website, they are able to articulate a knowledge graph. That's my takeaway from it.
Yeah, and that's what
This one.
Estie was saying is you add that semantic, can you see there, you add neo-semantics and now they can do it. Prior to that, they weren't able to do that.
And it sounds, so the stuff that I've read about on the different almost factions between property graph and knowledge graph in 2019 started to work together to come up with one almost standard that property and knowledge graphs can adhere to. So they're working on the RDF star type of extension, because at the moment, for example, Neo4j doesn't cater for Sparkle. You have to use their internally created cipher language.
I think Sparkle came after Cypher. I might be wrong, but I know that Neo4j was pushing hard to make Cypher the
actual
new standard, but they couldn't quite push it through.
That's
but I think they were before. I think Sparkle comes from
W3C.
APC. But I wonder if it was Apache who took it.
May have been, yeah.
Who sort of developed it, yeah.
But they got the backing from W3C, and then that brings about a whole lot of impetus. But I mean, let's go back to the fundamental thing: is are you seeing the difference between that property graph or the plane graph on the left-hand side? Then the knowledge graph has imported an RDF and connected the elements of the RDF to the different nodes that Ron, Verse, and Bike. I mean, can you see what the difference is between a property graph and a knowledge graph? Or is your question, or is your comment to say, well, I've always been able to do it with Neo4j?
Yeah, this is a very helpful picture, and I get that. That's not what I was struggling with. I was struggling with, and look, it's because my only dirty hands, as far as graph and so on goes, is really Neo4j. And I would like to actually talk a bit more with Estie in terms of what she did there, and get my own hands dirty on this level as well. Because what I'm struggling with is really, but it's clearer now. Thanks for the answers. But I don't. If I just look at this, then even from way back when I started playing with Neo4j, it was already a kind of a knowledge graph. It wasn't only a property graph in this picture. You know, if I just use this.
No, but let's go back. Were you able to design the ontology in a separate tool, bring it in, and then relate the nodes together? That's the question I'm asking. Or were you just doing it on a node, and then giving it a type on a node?
Yeah, look, I haven't had the opportunity or the need to do outside.
But you made the statement that, oh, I did that on Neo4j. So what did you do?
On Neo4j, well,
that's what you said in the beginning. You said, I don't see a difference because I did that on Neo4j.
Yes, we played with quite a lot of data, but that's starting with the data, bringing it in, and then typing the nodes, all the relationships.
But that's what I'm trying to say is you were typing the nodes, but what I'm trying to say is, were you importing a knowledge graph in the means of an RDF and then linking the nodes to existing knowledge graphs? That's the thing. That's what brings this world together.
No, I haven't done that.
So now with that neo-semantics, it's allowing you to do that. That's the change that's come about, that Neo4j has now allowed it to step up from property to knowledge.
Okay.
And then the support of course, that Sparkle that is doing that inference for you to be able to find the series of subclasses, or to work all your way down a complete categorization or classification taxonomy to find that node at the bottom or the parent node at the top. And now you're coding according to the knowledge graph and not coding according to the data.
Yeah, but still, even if you just start with the data, I mean, what you still get is it still creates I don't want to say schema, but you still get the structure. Whether you start with the data or just from conceptual modeling, that property graph picture that we looked at is really rudimentary. It's really very simplistic.
No, I'm not sure. So let's go back to the graph. I mean, yes, it is simplistic, but where the difference is coming in is how the ontology is different to the property graph and how those connections are made between that existing data in the property graph to the ontology.
Yeah, okay, so what you're saying is if there was no data and there was some sort of an ontological structure that somebody else developed, that's basically what Estie did. She pulled that into Neo4j using the new. Is that a module or a component, or how do they classify that, Estie? Is it a
that importer?
No, the neo-semantics.
Oh, it's a library, a plugin. They call it a plugin. So in my head, it's a library, but they call it a plugin.
Yeah.
So.
Yeah. Okay, that's cool. But I mean, Neo4j didn't stop you from creating.
No, it won't stop you because, I mean, remember a property graph is so easy. You can add any node to any node via an edge and call that node whatever you like. Does it understand it, or does it realize or recognize that it's a semantic definition? No, it's just another node. So it doesn't give you those extra capabilities to have that subclass hierarchy definition developing.
So as far as I can tell, like the neo-semantics before, if somebody else built a taxonomy that was an RDF format, you would have to rebuild it in Neo4j to be able to access it. Where now, with that plugin, you can now import the RDF or the OWL file. You import that.
Basically, the universe of discourse. You're building these ontologies to represent a domain and to represent the semantics of that domain. You're then bringing that in and via the neo-semantics, and then going through the process of associating the property graphs, the nodes in the property graph, to the ontology.
Mm. Yeah, okay, that's useful because the ontology, by definition, you need to bring in different structures in, right? Different taxonomies and so on. You have to mix them up together. We'll see how they relate.
Paul, this is almost what we were talking about. Is you could start with the data and then manually add the typings, and then extract the typings to say, okay, what have I got now? What have I discovered? But that's a very manual process, right? People are looking at the node and saying, right, this node is SBSA. Oh, right, that must be Standard Bank, which is an organization within the financial institution. So that knowledge is added manually to the node. And so you are able to do data modeling from the data up. So if you go and look at the nodes and say, oh, what is this? And that example that Estie has is a perfect one where I've got 3 elements here, but I can't connect them in. So what is it? What has happened there? It's data that's either lying to me or data that I don't know, meaning I need to update my knowledge, which is fantastic because now you're iteratively building your understanding of the domain. Certainly the challenge is you're going to get into the Bertrand Russell Barber paradox as a case of now I've introduced a cyclic graph here, and now I'm not sure how to put these things into which domain. That's an amazing representation of what don't I know. I mean, I think that's amazing that you can, and that was the beauty that they had of fiber and stuff like that, that you'd ingest all these transactions, balance sheets, and when you couldn't map nodes, it's like, jeepers, what's going on here?
Yeah, then it's either I guess an issue with the data itself, maybe a quality issue, maybe it is a new concept.
Yeah.
And that, but then you can follow the rabbit hole, right? You can actually.
Yes. But it's just looking at those that haven't been connected, right? So compared to all those other stuff that were all linked nicely, now I've got these orphans that are sitting here, and they shouldn't be. Everything should be connected, basically.
Yeah, and I guess also the sparsity of, I'm not sure what the right word is, but the number of connections between the objects is another thing.
Yeah. Now, Paul, what we did, I mean, there's also the scale size that clubs you, because we brought in in the central bank, the number of balance sheets was phenomenal we brought in. And when we looked just at the property graph, it sort of got to what Estie's was looking at, where you just can't make any sense. So showing business people that graph was interesting, but not really. No. Until we could map that thing onto a knowledge graph and then traverse. So give me all the elements that is this and all the children. So all the sort of derivatives on that thing, it left those guys hanging around. Now all of a sudden you could filter that graph to have almost like a laser focus on just the things that you are interested in. And you don't always have to get the one that's connected. You could get anyone that's in the parent, anyone that's in the hierarchy.
Okay, cool. But Estie, very well done. I mean, this is a great presentation.
Thanks, Howard, for your help too.
Thank you. Any other questions? Sorry, guys. I know Hans, does that explain a bit more for you as well? Are you?
Yeah, I'm really on the edge of graph anything. So I'm really just reading at the moment.
Understand.
I've stumbled across Tiger Graph, which one of their claims to additional fame is the so-called what do they call it, the parallel graph.
Yeah.
Where you have even more routes or ways to connect or relate your nodes or your data points. But yeah, no, I'm still very much looking for some more learning before I can really try and sound authoritative on graph. I'm here to learn effectively.
Understand, and I think that's sort of exactly what we're trying to do, is just show examples and give some sort of business examples of how we can tackle some of these classification issues and association issues in a more flexible way.
Well, the thing that got me touching graph, if I can call it like that, in the first place was the whole thing around customer 360 and master data management, where people are saying, I mean, again, not from an experience perspective, from reading, how they are using knowledge graphs specifically, to aid them to build that cohesive picture of customer 360, and also use it in master data management to ensure the quality of data and how the different components you might have that you're handling there to interrelate and all of that.
Yeah, and actually I had a great example of using this graph stuff in the central bank that was looking at KYC and looking at they discovered a scenario where someone was exporting money out of the country by getting 1,000 people to transfer money that they're given, and so that this guy was able to get around the limits on exporting. And what was done was that all those customers were brought into a graph, and one started looking at the relationships. So not so much from a sort of customer per se point of view, but it was about transactions linking to customers, which generated relationships in terms of who was talking to who and who was interacting with who, to discover the behavior of these transactions. And so the KYC data was coming in, and then they were bringing in transactions, and then together these things started to tell a story of people performing this type of scenario. So,
well, I've read those descriptions of how people say they've used graph to show them relationships that they didn't even know existed.
Yeah, and it is about the transaction or the balance sheet. So we had two experiences, one with transactions and the other one was with balance sheet data. And then, for example, we were finding crossovers of who owned who and who was involved with where, and that was all part of a risk analysis to say, if this person failed, who else would fail?
Yeah.
Okay, great.
Cool.
Estie, thank you very
Howard,
much. Yes.
actually, a question on that. So if they're using the data, so then they aren't using models to that whoever built it inherently builds bias in there as well, whether we intend to or not. But because you're looking at the data of who actually had a problem, or am I missing?
Yeah, I'm not. So just help me again. Which one was it? Was it on the balance sheet one or the in and out flows on the country?
The in and out flows in the country.
So remember, the KYC is something that all banks have. Whenever somebody transfers money in and out of the country, they have to go through that know your customer. And that's part of the master data. And then all of the transfers are related to that know your customer. Now, what happened was that there were a series of transactions that were performed, and there was a correlation between the amounts. So what the person wasn't very clever on is they didn't give different amounts, they gave the same amounts, and they all happened within a 10-minute period. So we had certain filters that we could reduce the graph and find relationships.
Like that. Okay, cool. Okay, cool. I'm on the same page now.
And especially when some of them, they didn't have much money to their name, and one of them was very rich.
Yeah, definitely flags an anomaly.
So it was an amazing, I mean, it didn't happen overnight. There were several things on trying to find it. Someone got wind of it, and then you have to go looking for it. But you constantly have to be adding information or typing to be able to filter the noise, to be able to filter that mass of transactions to get to what you're looking for.
Yeah.
And that's where I recognize the benefit of the separated domain or knowledge domain, that I could bring it in and link it, whereas we were doing it manually on the graph.
Thanks. I'm now on the same page.
Okay.
Thanks.
Fantastic. Thank you, everybody.
Angry cloths. Thanks.
Quite lapis.
Okay. Thanks, everyone. It was a good session.
Everybody. Oh, I better
Bye,
switch.
everyone.